Hello students, आप लोग कैसे हैं? I hope you all are very fine and studying on consistent basis. So I welcome you in my YouTube channel, and today we'll be discussing some very interesting questions, right? Which are based on the concept of impulse and the change in the momentum. I mean the law of conservation of linear momentum. These are the topics which we have already discussed in the previous lectures, right? So let's start with the numericals then. Let's concentrate on the first question. The question is, calculate the impulse necessary to stop a 1500 kg car traveling at 90 km per hour. So we are supposed to find out the impulse. So students, first note down the things which are given in the numerical, right? The given information. So given information is mass of the car. It is given to be 1500 kg, right? Then it is initially traveling at 90 km per hour. So initial velocity is 90 km per hour. Student, while doing numerical, just keep this in mind so as to convert each and every physical quantity into a single system. Represent every quantity in a particular system, right? Here obviously we'll make use of SI system. So what we get is 1 km per hour is 580 meter per second. So it would be 25 meter per second, isn't it? Okay, now impulse necessary to stop a car. So finally the car is coming to rest, so its final velocity is 0. Now look, we need to get the relationship in these three, and impulse is to be calculated. Now try to recall the formula relating these physical quantities. Students, we are aware impulse is numerically equal to the change in the momentum of the body. So we will be making use of this formula in solving this question. So impulse, let us denote it by I. It is change in the momentum, means final momentum minus initial momentum. Momentum is mass into velocity. So final momentum would be mass multiplied by final velocity. Initial momentum is mass multiplied by initial velocity. So it is mv minus u. So let's solve it. Mass is 1500. Final velocity is 0 and initial velocity is 25. So if you solve it, 15 into 25, that will give us 37500, and its SI unit is Newton second, force into time, isn't it? And if you expand it in basic units, it will be also written in the form of kg meter per second. It is impulses change in momentum. So it will have the same unit as that of momentum, that is kg meter per second. So either you can write Newton second or kg meter per second. So this is the answer, student. This is the impulse. Minus 37500 Newton second. Now tell me, what does this negative sign signify? The negative sign over here signifies the fact that in this case the impulse is producing a retarding effect so as to bring the car into rest. Right? Okay. First question is over. Now let's concentrate on the second question. Second one is again quite interesting question. It is based on the law of conservation of linear momentum. So students, concentrate on the second question. A 30 kg shell is flying at 48 meters per second. When it explodes, its one part of 18 kg stops while the remaining part flies on. We are supposed to find out the velocity of the latter one, the second part, right? So this is it. The shell is of mass 30 kg. Remember, this is a shell of mass 30 kg. And it is initially moving with velocity of 48 meters per second. So what is the initial momentum then? Initial momentum of this system, that is Pi, it is equal to mass into velocity, that is 30 multiplied by 48. It will be in kg meter per second. This is the initial momentum, right students? Now, when it explodes, one part of 18 kg stops. It explodes. One is of 18 kg. Suppose this is m1. It comes to rest. Its velocity is 0, right? And the other fragment Out of 30 kg, this fragment is of mass 18 kg. So naturally the other fragment would be of mass 12 kg. So this is the other fragment. This is of mass 12 kg. So its velocity is to be determined. This fragment is at rest. So this is what we are supposed to calculate, right? So students, the explosion of a shell or a bomb, it's due to the internal forces. No net external force acts on it. And the sum total of internal force acting in a system is always 0. So here, no net external force acts on the system. Therefore, as per the law of conservation of linear momentum, the momentum of the system must be conserved. That is, initial momentum must be equal to the final momentum, isn't it? Let's find out the final momentum. Final momentum would be mass into velocity, 18 into V1. Its velocity is 0. Plus, its mass is 12 and its velocity is V2. So this is the initial momentum and this is the final momentum. Since no net external force acts on the system, therefore momentum is constant or conserved. Therefore, final momentum is equal to initial momentum. It is equal to constant. This we have also discussed theoretically, right? We have verified the law of conservation of momentum, isn't it? So final momentum is 18 into 0 is 0. So we will be left with only 12 V2. And initial momentum is 30 into 48. So let's get the answer. V2 would be equal to 30 into 48 divided by 12. So 12 4s are 48 and 30 into 4 is 120 meter per second. So the fragment of mass 12 kg will move with velocity of 120 meter per second. Right, students? So this was a very useful question based on law of conservation of linear momentum. Right? Okay, now let's concentrate on the third question. A cricket ball, students, let's consider the third question now. A cricket ball of mass 500 gram, the mass is given to be slightly larger. Actually, the mass of a cricket ball is about only 150 grams, right? Anyway, we'll proceed with the question. A cricket ball of 500 gram is moving with speed of 36 km per hour. It is reflected back with the same speed. What is the impulse applied on it? Okay, this is again a very interesting question based on reflection, right? So, mass of the ball, that's given to be 500 gram. Let's convert it in SI. So it will be 0.5 kg, half kg, right? Moving with speed of 36 km per hour. So what is the initial speed? 36 km per hour. So it can be converted into meter per second. So it will be 5 by 18 meter per second. So that will be equal to 10 meter per second. Isn't it? 1 km per hour is 5 by 18 meter per second. Now, it is reflected back with the same speed. Now look, this is suppose the ball. This is suppose a wall or a cricket bat, and this is the ball, which is moving with initial velocity u, right? After getting reflected, it retraces its path in the opposite direction. It is reflected back with the same speed. So, it's coming like this. It will rebound, it will bounce back, and it is moving with the same speed. So, magnitude of V is equal to magnitude of U, right? But the direction of motion is different. Here, initially, the ball is going from left to right. But after reflection, the ball rebounds and it will move in the opposite direction without change in its speed, right? So now after reflection, it is moving from right to left. So the direction of motion, they are different. So over here, if this is considered to be the positive sign, then this will be considered to be the negative sign, right? So we need to find out the impulse. So impulse, we are aware, it is change in the momentum, Pf minus Pi. So it is mass into final velocity minus initial velocity. This is the change in the momentum. What is the mass, students? 0.5 kg in SI. What is the final velocity? Let's consider this to be positive. So this direction would be considered to be negative. So V is positive over here, right? So V is given to be, this velocity is given to be 10 meter per second. speed is same in both the cases, right? It rebounds with the same speed. Minus, what is u? U is along this direction, which is considered negative. Both are in the opposite direction. So one would be the negative of the other. So it will be minus 10. So what do you get? 0.5 multiplied by minus plus, it will give us 20. So it will be equal to point and this get cancelled. So it will be 10. And unit is Newton second or kg meter per second. So this will be the impulse applied on it. Clear, students? So impulse is the change in the momentum. So what's so important in this particular question? The direction which you are supposed to take. Since the ball is changing its direction of motion. Now after rebounding, after reflecting, it is retracing its path in the opposite direction at the same speed. So its direction of motion gets changed by 180 degrees. So as a result, initial and final speed, although their magnitude are equal, but they are of negative sign. One is negative of the other. Clear, students? So that is what we have used over here. So this is the answer. Okay, now let's proceed with the fourth one. We are over with question number 1, question number 2 and question number 3. Now let's concentrate on question number 4. Okay, a force of 10 Newton. First write all the information whichever is given in a numerical. Acts on a body for 3, this is the symbol for micro. So time is given 3 microseconds. And students, micro means 10 raised to the minus 6. So don't forget to convert it in SI. 1 micro means 10 raised to the minus 6. Right? Calculate the impulse. So impulse is to be calculated. If the mass of the body is given to be 5 gram. So it will be equal to 5 by 1000 kg. Again I repeat, convert it in SI. Calculate the change in the velocity. So change in the velocity is to be determined. Change in the velocity. Change in the velocity means final minus initial. Always remember, change in a physical quantity is the final value of that physical quantity minus initial value of that physical quantity. Right? So these are the two parts which needs to be evaluated. Now what's the relationship in these two? Impulse, we are aware, it's given by the product of magnitude of the force and the small duration of time during which it acts. Right? So what is force? 10. What is the time during which this force acts? It is 3 microseconds. So if you solve it, 3 multiplied by 10 is to the minus 5. Newton second. Unit of force is Newton, time is second. It can also be written as kg meter per second. Right? So this is the answer of the first part. Now let's try to find out the second part. Right? Impulse, we are also aware, it's given by the change in the momentum. And change in the momentum is mv minus mu. So m can be taken as common, v minus u. Now look, we are supposed to find out this. Therefore, change in velocity, this is what is required to be found. That is v minus u, it will be equal to I divided by m. That is impulse divided by mass. So, change in the velocity would be equal to impulse. This we have already determined in the first part. 3 into 10 to the minus 5 divided by mass. Mass is given to be 5 gram. That is 5 divided by 1000. So let's try to solve it. So it will be 3 into 10 to the minus 5 multiplied by 1000 divided by 5. Isn't it, student? So what we get is 3 by 5 into 10 raised to the power minus 2. Isn't it? Or change in the velocity is 0.6 into 10 raised to the minus 2. In SI, velocity is meter per second. So this is the answer. So change in the velocity, students, is 0.6 into 10 raised to the power minus 2 meter per second. So we have obtained the answer of both the parts, the impulse and the change in the velocity. Right? Okay, proceeding further, we are done with question 4 as well. Now let's concentrate on question number 5. This is based on the recoiling of gun. This topic is based on Newton's third law, action-reaction, right? And it can also be verified using the law of conservation of momentum, the recoiling of gun. When a bullet is shot from a gun, then bullet moves in the forward direction, while the gun tends to exert a force in the backward direction. That is known as the recoiling of a gun. So this is a question based on this concept. So let's try to attempt it. Okay, question number 5. A gun weighing mass of the gun, suppose it's repelled by capital M, it is 10 kg. This is mass of the gun. A bullet of mass 50 gram. Suppose the mass of the bullet is written by small m, it is 50 gram. So it will be 50 by 1000 kg. Don't forget to convert it in SI. With a velocity of 500 meter per second, the velocity of the bullet is, final velocity of the bullet, it is given to be 500 meter per second. With what velocity does the gun recoil? Capital V is to be determined. So here what I have considered is, capital M is the mass of the gun, small m is the mass of the bullet, small v is the mass of the bullet after it is fired, capital V is the velocity of the gun, that is the recoiling velocity, right? So let's do it. As theoretically I have told you this concept, but let me repeat it again. This is a trigger, suppose, right? The mass of the gun is m, the mass of the bullet, it's considered to be small m. Initial velocity is small u, its initial velocity is capital U. And once the bullet is shot from the gun, its final velocity is v, and the recoil velocity of the gun is capital letter V, right? So, since there is no net external force, therefore the momentum is conserved. So, initial momentum would be mu plus capital M. This is the initial momentum of the bullet. This is the initial momentum of the gun. It should be equal to the final momentum of the system. And the system comprises of bullet and this gun. Final momentum of the bullet is mass into final velocity plus final momentum of the gun is capital M into capital V. Now since initially the bullet is inside the gun and the entire system is at rest, therefore initially U is equal to capital U is equal to 0. Therefore initially U or capital U is equal to 0. So this becomes 0. mv plus mv. So rearranging the terms, what you get is v is equal to minus m by capital M into small v. So this is the relationship, and using this formula we can easily obtain the recoiling velocity of the gun, right? So let's substitute the value. Mass of the bullet, it's 50 divided by 1000. V, velocity of the bullet, it's 500 divided by mass of the gun, that is 10. Let's try to solve it. So it is minus 25 by 10. So it is minus 2.5 meter per second. So students, this negative sign in the velocity of the gun indicates that if the bullet moves forward, then the gun will move in the backward direction. So that's the recoil velocity. So recoil velocity of the gun is 2.5 meter per second. Clear, students? So when such a numerical comes, you can use this formula directly, right? No need to derive it time and again, right? In numericals, you can make use of this formula directly. Okay, so we are over with question number 5 as well. Now question number 6. It's again the concept of impulse. A hammer of mass 1 kg strikes on the head of a nail with a velocity of 10 meter per second. Okay, the mass of the hammer is 1 kg and it strikes on the head of a nail with a velocity of 10 meter per second. So the entire velocity will get imparted to the nail, isn't it? So initial velocity is 10 meter per second. It drives the nail 0.1 meter into a wooden block. It will get penetrated inside the wooden block, and after that the nail will come to rest. So final velocity is 0. And during this change in velocity, it has covered a displacement of 0.1 meter, isn't it? calculate the force applied on the hammer, F is to be calculated, and the time of impact is to be determined. So students, here the question is, hammer is being struck on the nail with a velocity of 10 meters per second. So initial velocity of the nail would be same as that of the hammer velocity, that is 10 meters per second. And after penetrating a distance of 0.1 meter inside a wooden plank, the nail will eventually come to rest, so its final velocity will become 0. And during this change in the velocity, it has covered a distance of 0.1 meter inside the wooden plank. Right? So mass of the hammer is given. So what we can do is, we can apply the equations of motion and then get the acceleration, and then force will be given by mass into acceleration, isn't it? So what to do is, can you remember any equation relating these three? Yes, it's the third equation of motion, displacement velocity relationship. What's the relationship? 2as is equal to v square minus u square. This is third equation of motion, right? So 2, acceleration, that is to be determined. What is the displacement covered? 0.1. Okay, final velocity, it's 0. Eventually the nail will come to rest, or hammer will come to rest eventually on striking the nail. Initial velocity of the hammer, it's 10. So let's solve it. A would be equal to minus 10 square, it would be 100, divided by 2 into 0.1. So A would be equal to minus 1000 divided by 2. So A would be equal to minus 500 meter per second square. So this is the retardation produced. Negative sign suggests that it is the case of retardation, isn't it? So what will be the force? It is equal to mass into acceleration. So what do you get? Mass is 1 and acceleration is minus 500. So it will give us minus 500 Newton. Negative sign suggests that this is the retarding force, right? So first part is over. This is the answer of the first part. So force we obtained is 500 Newton. Negative sign suggests that it is a retarding force. What about the time? Now, in order to find out time, what we do is, we are aware impulse, it is equal to force into time. Also, impulse is equal to change the momentum, final momentum minus initial momentum, that is mv minus u, isn't it? So you can equate these two. So what do you get is, F multiplied by T is equal to mv minus u. Therefore, time can be obtained by using this formula divided by F. So let's substitute the values. M is given to be 1 kg. Final velocity is given to be 0. Initial velocity is given to be 10. And force is given to be minus 500. So what do you get is minus 10 by minus 500. So what do you get? 1 by 50 seconds. Or it is equal to 0.02 seconds. So this is the time of impact. So students, both the parts of question number 6 is over, right? So I hope you have understood these questions, and as always I maintain, please practice more and more numericals. The more you practice, the better you will get, and the more you will gain in confidence while solving numericals, right students? So we'll continue in the next lecture then. All the very, very best. Do practice these numericals and try some additional questions as well, right? Okay, bye bye students. Do take care of yourself. Thank you.